Good morning, everyone. Welcome to today's training of Getting Started with Kubernetes. My name is Denise Shannon. I'm joined here today with my coworker, Josh. Josh, you want to say hi?
Yeah, hey, everyone.
Okay, so today's objectives, we're going to be doing a technical introduction to Kubernetes using Rancher. I have a couple of slides, not that many. We'll be doing a lot of demoing. And then basically, if you have questions, please feel free to ask them. There is on the GoToWebinar on the side. If you open up your control panel, there's like a question section. You can ask questions there. When I'm doing my demo, Josh will be helping answer your questions. And then during his part, I'll be either answering them through the GoToWebinar and posting the answers, or sometimes if it's a lot of people asking the same questions, I'll end up interrupting or asking Josh verbally so that he can answer it so all of you can know. Okay. I did not update the slide. So for the purpose of this training, we do, assume you have some basic Docker concepts, we do have a intro to Rancher training. So this one is our Kubernetes specific one. I won't go into details of how you can set up Rancher, the different concepts within Rancher itself. That we do in a different training. The next session is not obviously Thursday, August 10th. It's going to be Thursday, September. It's usually the second Thursday of the month. So in my calendar real quick, it'll be Thursday, September 14th. If you go to rancher.com/training, you can sign up for that. A couple of resources. We have a doc site. It lists out a bunch of stuff, a little bit of the concepts that we'll talk today in Kubernetes. So there's a Kubernetes specific section. We have our forums. There's a lot of people who in our community will answer stuff there. And then, so the key topics of today is setting up Rancher. So I'll be doing setting up Rancher and deploying Kubernetes. I'll hand it off to Josh, and he'll do working on setting up kube control. He'll talk about, he'll probably be going through basically the concepts of these Kubernetes topics through slides, and then he'll be demoing how to use them and what they mean in Rancher. So sometimes people ask, like, why Rancher and Kubernetes? There's a lot of marketing bullet points here, but basically for me, I think it's great because you can, the one-click deploy of being able to get Kubernetes up and running. It's super easy to use. When new Kubernetes versions come out, it's, we'll certify it against Rancher. You can then, the one-click upgrade where you just upgrade and then you'll get, the most recent Kubernetes distro that we support. Rancher itself allows you to be able to do management across multiple different clouds, like where you have your hosts or nodes. Those can be across the board, and we're able to schedule across those. Okay, so then let's see. I'm going to get out of the slide deck. Okay, so for today's demo, what I have is set up 4 boxes. I set it up in AWS. I actually just pulled our AWS Rancher OS image as just boxes to use. You can use any Linux distribution as long as it has Docker installed on it. It will work. That's a common question. You do not need to use Rancher OS with Rancher. All I've done is I've started our most recent version of Rancher, which is v1.6.7. I have also started up these 3 other boxes, and all I've done before the demo is just pre-pulled images onto them, so during the demo it'll be faster. So as I said before, I'm not going to cover over how the details of setting up Rancher. Basically, once you start it up, you can go to 8080. That's the port that I exposed for my Rancher server container. You'll come into here. The first thing I will do is I'm going to turn on access control so no one else can access my site. Enable off. I'm going to also quickly add in an account for Josh. So when he takes over, he can see what's going on. I'll make him an admin. So I have me and Josh now up. So when you come into Rancher, when you first come in, you're going to be in this, what we call default environment. You'll want to go to Manage Environment. You'll see that this default environment is coming from a cattle template. So we have these default environment templates, which basically are the different container orchestrators that we have of what you can use. All I'm going to do is show you a couple things. So one, currently, the default Kubernetes template takes in all the defaults of a Kubernetes setup. If you wanted to edit the existing template, you could come and edit the template. You could come to the Kubernetes catalog item. You would click Edit Configuration, and you can see all the different configurations that we have. So one quick note is for template version. Usually we have one version of Kubernetes that we support or test against for each Rancher version. Usually we try and pick the latest Kubernetes version that's out there when we release Rancher. For Kubernetes itself, there's a lot of configuration options that we have. I'm going to pull up the docs site real quick. Go to Kubernetes, launching Kubernetes. Kind of what I'm talking about now is also in this doc site for anyone, if you want to go look and be able to follow along later and have more questions or want to read more about it. So some of the configuration options include like plane isolation. So by default, there's none. If you're going to do a production setup, we recommend isolating your planes. What it means is basically your data, orchestration, and compute planes will be isolated, so the hosts that you add will be different. So your data one is basically our etcd. Those would go, the etcd containers would go on specific hosts that are dedicated just for that. There would be an orchestration host, and that one would be containing all the components that we use to launch and be able to set up Kubernetes. And then the compute planes are where basically the kubelets run, and then you have the ability of any services that you're starting up in, or anything that you're starting up in Kubernetes, go to those hosts. So by default, it's off. So if you want to be able to turn it on, you have to edit your configuration options to require it. There's some things that you'll need to do, like add in host labels to your hosts to be able to get that working. Here, there's different cloud providers. So if you wanted, like by default, uses Rancher. By using the Rancher cloud provider, if you use an ingress, you'll get Rancher's load balancer, which is HA proxy software. There's some other options. If you want to use only AWS hosts and ELBs, you can pick the AWS cloud provider. We now have support for Kubernetes RBAC. By default, it's turned off. If you have private registry, there's you would put your private registry here so that when we start things, it would know to pull from your private registry. There's a lot of other options. Let's see, the next couple ones are probably the only ones that are applicable, and then after that, it's probably pretty more advanced or complicated, where one is like your DNS service. So by default, it's a scale of 1. So if you want HA for your DNS service, you would change that to how many hosts that you have or what you want to scale it up to. By default, we enable Rancher's ingress controller. What that means is if you start an ingress, it uses Rancher's load balancer. You can disable that so that you could use other ingress controllers if you want. We turn on what we call our add-ons. These are like dashboard, home, DNS. By default, that's enabled. I don't know how many people would ever actually turn it off, but if you wanted to, you could. And then after that, there's a lot of, the bottom ones are a lot about the like etcd and backup. So I'm actually not going to change anything in my configuration. I leave it like that. Cancel out of this. I'm going to add an environment. When you add an environment, you basically pick an environment template. I'll pick Kubernetes. create that, I'll have to add Josh as a member of my environment, so when he logs in, he'll be able to see the Kubernetes environment. Environments are just basically the ability to isolate your resources, and so you can have multiple environments where one is like dev, test, and production are usually the examples we usually give of how you might separate it. I'm going to create this one, and then I'm actually going to switch to Kubernetes. So when you first add a Kubernetes environment, what happens is it's going to just kind of sit here, and you're not going to be able to do anything until you start adding hosts. I'm going to go to the Add Hosts page. I'm going to grab this command that basically runs a Rancher agent container. It's going to run it on all my hosts that I have, and basically add these hosts into Rancher. Oops, it's going to work. Now that I've added it, you can see the Rancher agent container is running, and on these other ones, there are other services that are going to start spinning up. So here you can see I have those 3 hosts that I had added in. One thing to note about Kubernetes and Docker versions is that Kubernetes itself only supports up to Docker 1.12.6. So whatever hosts that you use, make sure that your Docker version that you install is 1.12.6, otherwise it won't work. And now I'll go to my infrastructure stacks, and you can see these are all the stacks that we're starting up. By default, Rancher kind of requires these network services, IPsec, health check. Those services are what's used to basically schedule the Kubernetes containers in terms of being able to deploy Kubernetes. This is what sets up your managed network within Rancher so that your hosts can communicate across with each other. Health checks allow to be able to check the health state of your containers in your setup. And then let's open up Kubernetes. Now for Kubernetes itself, we have lots of different services that we have up and running to be able to get Kubernetes running. I'm not going to go into any details of what each piece does, but these are all the components that usually are needed to get our Kubernetes stuff running, and it usually doesn't take that long, especially because I've pre-pulled all my images before eventually this Kubernetes stack should become active. And once it becomes active, you'll be able to, even though it hasn't refreshed here, but you can see that it's active now, where I should be able to go to the CLI. Here you can download access to be able to set up your kube control, or you can use the shell to be able to see what's going on. Oh, that's new. Okay. Let's go first check out. Okay. Let's see what's going on. So usually you can start using the shell and it starts working fine.
We don't like it. We could just use the generate config.
Okay. I can see that those services are still stuck in initializing phase, so maybe they're up and running. My dashboard is not running. Okay.
Which ones are initializing?
Controller manager, kube control shell. Sorry, so as it gets up and running, we'll take a look and try and see why. We'll do some live debugging of why it's not working. Okay, everything is in theory active now. Go to our CLI now. See if this. Okay. Everything is now up and running. I think before, when I tried to access it, there is one that's called kube control shell. That was one of the services that was stuck in initializing, so it might not have actually set up and was ready. But now you can see that my kube control in the shell is now working. I can check out what my nodes are. What is it, kube system?
Yep, kube system.
So then I'm gonna check. Is that right?
Yeah, you should. Yes.
So I was checking to see if our add-ons, which is what our dashboard was up and running. It doesn't appear to be running right now. Let me take a look on our hosts. Let's see. Looks as if our add-on starter, which starts all those, has not started any of those additional ones, because usually you see it. So let's see. So let's go into our add-on starter. And it looks like it's green. Okay. Well, okay, I'm gonna I'll look into this more. I'll get Josh to start talking about some Kubernetes concepts and then start hopefully being able to demo. I don't think the add-on starter is necessary for his demo. Okay. He has told me that he does need DNS. So we will need to look more into this. Maybe I'll just restart it.
Or if you want, you can go spin a new cluster, and I'll use this one until I get to services I need till then.
Okay, I'll try. So what Josh has suggested is that, to get the demo, or at least the training continuing, he'll start using this one. He'll be able to start talking some concepts and start showing you some things. I'm going to basically do the exact same thing that I've done here. I'm just going to start a new cluster, so I'm just going to create a new environment. With it, I'll probably add some hosts through DigitalOcean, get it up and running. It'll take a little bit longer because I don't have the images pre-pulled, and hopefully that will get up and running and I can get him a setup that's working. So let me hand it off to Josh so he can start sharing his portion. See where, why, oh, there you are. Okay, I believe everyone should be able to see his screen. I can see it on my end, so it looks like we're good.
Cool. Okay, ready to get started then. Okay, so the first concept I'm going to discuss is that of a pod, which is like basically the fundamental unit that you're going to deploy things in Kubernetes. So when a lot of new users go and they start using Kubernetes, they expect to be able to just go and launch containers, but that's actually not something that you can do directly in Kubernetes. So to launch a container, you would put it inside of a pod. So a pod is one or more containers that are always scheduled to the same host, and then it's the basic unit. So each pod is given a unique IP address that can be used within the cluster. So within Rancher, each pod is going to be given a unique IP address on the Rancher IPsec network. So then traffic between pods is encrypted. So then within a pod, containers can actually communicate with themselves via localhost. So if this concept is a little bit confusing right now, that's okay. The idea of pods is a little bit more of an advanced topic, but it's something you have to discuss up front because it is the smallest unit that you can deploy in Kubernetes. So in most use cases, you're actually only going to have one container inside of a pod. So if this is confusing for now, just try to think of pods and containers as being the same thing for now. So now I'm actually going to go and demo just launching a few pods to the Kubernetes cluster that we set up. So I'm going to go to the Rancher UI and generate a new kube config. And this is something that I can use to access the Kubernetes cluster via the kube control command, which is the main CLI of Kubernetes. So I'm going to place this in my home directory and then under .kube and config. And then I should be able to do for my terminal kube control get node just to see like what nodes are currently running in the cluster. And then from here on, we can use the kube control command locally to access the cluster. So the first thing I'm going to show is just launching a very simple pod in the cluster. So I'm going to take a look at the nginx pod. So this is a Kubernetes YAML file, or Kubernetes resource represented as a YAML file. So we can see here that we define an API version. So each resource has different versions. Most of the common ones you're just going to see are v1, like pod and some of the other ones. And then we define the kind here as pod, and then some common metadata, which will be the same across most resources. In this case, we're going to give it a name, which is kind of like a unique identifier for the pod. And then under spec, that's going to be where we define which containers are going to be inside this pod. In this case, we're just going to have a container called Nginx, which uses the Nginx image and exposes itself on port 80. So to create this resource, I'm going to use the kubectl create command. So kubectl create can be used with any Kubernetes resource file. In this case, we're going to give it the Nginx pod resource. Okay, so you can see that the pod is created, and then we can use the kubectl get command to see all the pods that are currently available. So if we do kubectl get pod, we'll see Nginx has been created and it's now running. So if I go back to Rancher and I take a look at the host tab, I can see that Nginx is now running on one of the hosts here. Okay, so the next thing I'm going to do is just deploy another pod called shell. And this is just a pod that has a container that sits there and sleeps. So later on in the presentation, I'm going to use this to show communicating with other pods in the cluster. So this is something that I can exec into and have a shell that's within the cluster. So I'm going to use kubectl create on this as well. And I'm going to do kubectl get pod just to make sure that it's running. And you can also see that it just popped up here on the left. Okay, so now I'm going to use the kubectl describe command to just list some basic info about the Nginx pod. So there's a lot of different information here. The most important that I'm looking for right now is just the IP address. So I'm going to copy this, and then I'm going to exec into the shell command, the shell pod that I just launched. Okay, so now I'm actually running a shell inside the container itself, which means that it's running within the network. So I can do curl the IP address that we looked up earlier, and then we can see that it's communicating with the other Nginx pod that's running inside the cluster. Okay. So the next topic I'm going to discuss is that of deployments. So we just went ahead and launched a pod, which is launching a pod directly is somewhat of an anti-pattern in Kubernetes. So usually when you're launching services, you're going to have some kind of desired scale. Even if that desired scale is 1, you'll still want to use a deployment for this. So these are a level of abstraction above pods where you define both the desired state of the pods and the desired scale of the pods. So instead of launching pods directly, we're just going to use deployments now. So some of you, if you have looked at other Kubernetes tutorials in the past, you might see the terms replication controller or replica set. So these are two other similar resources in Kubernetes for doing similar things. Replication controller is found to be superseded by deployments, and replica sets are actually used behind the scenes in deployments. So if you're just starting out in Kubernetes, it's probably best just to use deployments. If you have some other use case where you would rather use these, it's possible, but it's more likely that going forward, everything is just going to be deployments. So now I'm going to navigate to my deployment directory. So the first thing
Oh, sorry. One thing that you might want to do, no, there's not a question, is remember if you uncheck the show system, you might be able to then see your containers that you're setting up a little easier for people who are trying to see what you're doing.
Thanks, that's it. Okay, so this is another Kubernetes resource file that I have defined here. So instead of being a pod, we have kind deployments. And then under spec, we also have a new replicas field, which just defines how many pods we would like to be run. And then under template, this is actually the same spec that was previously used under the pod one. So we still have like the standard metadata. And then we're also going to append a new label to every pod that's created for this deployment. And we're just going to add the label app Nginx. And then under the spec, we can see it's exactly the same as before, except we're now using the image Nginx 1.12, just so we can have a specific version attached to it. So I'm going to go ahead and create this deployment with kubectl create, which is the same command we used before for pods. Okay, so you can see that the deployment is created. So we can also do kubectl get deployments as well, and that will list all the deployments available. So you can see that the Nginx deployment was created. Now let's actually check to make sure that the underlying pods are being created. Okay, we can see that there are 3 new Nginxs, each with like a unique hash appended to the end of it. So these are the pods that are being managed by the new deployment. And if we look on the left, we can see that these Nginx containers were spread across our various hosts. So just for the sake of demo, I'm actually going to go and delete one of these pods just to show that when there is a case where the desired state is not met, the deployment is actually going to go and reconcile that state and create a new pod. So I'm going to use the kubectl delete command to do that. I'm going to do kubectl delete pod, and then just the first one from this list. And then if I do kubectl get pod again, we can see that that one's terminating and another new one was created. So now our desired scale is still met. All right, so next thing I'm going to do is I'm going to show a couple of different ways you can update existing deployments. So deployments are nice for launching new services, but they're also very useful for modifying existing ones. So the way to do that is you'll modify the desired state, and then the deployment will be responsible for actually going and updating the underlying pods to what you're looking for. So the first one I'm going to show is the kubectl scale command. So this will just purely change the desired scale of an existing deployment. So I'm going to do kubectl scale and then deployment / nginx, which is the name of the deployment we launched already. And then we're going to change the replicas to 2. So now that when I do kubectl get pod, I should see 2 nginx pods instead of 3 running. So next I'm going to use the kubectl edit command. And this is something that can actually be used with any resource that you've launched into the cluster. So in this case, I'm just going to edit the scale back to what it was previously. So I'm going to type kubectl edit deployment nginx. And then here I can see under spec that the replicas are 2. So I'm just going to change that to 3 and then exit. And we can see that it was edited. And then when I do kubectl get pod again, I can see that we're back at 3, the desired scale of 3.
One quick question. Someone asked, can we have multiple containers in a deployment YAML file?
It depends what you mean. So you could have multiple containers inside of a pod, and then when you change the scale of a deployment, each of those containers in the pod will be scaled up along with it. So if you have 2 containers inside of a pod, and then you set the desired scale to 3 of the deployment, you'll end up with 6 containers. It could be that you're thinking the use case is, maybe
it might be like 2 different types of pod, or like 2 different. I'm speculating.
Yeah.
What the question is, but it could be, could you have multiple like pods in a deployment file?
Yeah, you cannot have multiple pods in a deployment. So to do that, you would just create another deployment.
Okay. Hopefully that answers your question. If it doesn't, please feel free to ask another one.
Right.
A follow-up.
So it's not like if you're familiar with compose files, it's not like a stack where you can just add multiple services. A deployment is more like a service in compose. So like if you wanted to have like another pod, you would just create a new deployment.
Someone else also asked, sorry to keep interrupting, if there is a tool or a command out there that would generate Kubernetes YAML files.
Generate them? From what?
I'm not sure. I know when I started, probably the most intimidating part is like, how do you get these YAML files that you're creating? And so maybe I think maybe they're trying to ask what's the easiest way to be able to do it.
There are tools out there where you can kind of use templating to generate some of these for you. It might take a while to actually list off all the available tools out there. One of the most common ones is actually Helm, but you still kind of want to be familiar with the underlying YAML resource even when you're using some kind of like templating engine above it. So Kubernetes YAML files are pretty verbose. They're pretty intimidating, but when you actually get down to it, they start looking more and more familiar when you work with them more. A lot of it is just kind of boilerplate between each YAML file, but some of that can be, once you get used to that, you can move up to a templating engine and you can avoid some of the boilerplate, which is nice. Okay.
And then another quick thing is I did spin up another Kubernetes cluster. The add-ons did start. So if you want to switch to there to try and you need it for
I will switch to it before the next section.
Okay.
Yeah. Cool. Okay. So the next command I'm going to show is actually a very useful command, and that's kubectl apply. So previously, we just used the kubectl create command, which just takes and applies, and it creates any resource in a given file. But if I were to go back and try recreating the same resource, Kubernetes would throw an error and say, hey, this resource already exists, therefore we can't create it. So the kubectl apply command does is, it looks and it sees if there's an existing resource already for that. If it exists, then it updates the existing one, and if not, it creates it. So in this case, I'm actually going to go and I'm going to edit the Nginx deployment YAML file, and I'm going to change the image to Nginx 1.13. So if I were to do kubectl create here, it would fail. So instead, I'm going to do kubectl apply, and then the deployment's actually going to go and be edited. Okay. So now I'm going to go and do kubectl get pod, and look at what's actually being created with this pod. So now I'm going to show the kubectl get command with the -o flag, which just basically exports the current state of this resource within Kubernetes. And -o YAML. So you can see here, this is basically defining like all of the various things in Kubernetes. So whenever you create a resource file, Kubernetes is actually going to go and store that and have an internal representation of it. So if we look here, we can see the underlying image being used is Nginx 1.13. And so all of our deployments were upgraded successfully. And the method that Kubernetes uses to update these is they'll just slowly delete the old pods and slowly recreate the new ones. And there's various configuration available for defining how many of the old ones you want to delete at a time and how many of the new ones you want to create at a time. There's like different configuration available there. Okay, so lastly, I'm just going to do one more command just to show another way of launching deployments. So I'm going to do kubectl run, which is kind of similar to Docker run, except it's going to go and create a deployment. Kubectl run, and I'm going to call this Nginx 2, and then I'm just going to use the Nginx image again. And then we can see we have another deployment that was created. And let's just check on that. Okay. So the next topic I'm going to discuss is that of services. And I'm actually going to go ahead and switch clusters before I talk about the slides for that. So what IP address?
Oh, it's the same one. It's just in a different environment.
Oh, different environment. Okay.
It's just a different environment. If you refresh, you should be able to. I believe I gave you access to it. You'll have to update your kube config.
Yeah. All right. So I'm just going to update this to a new running cluster. And I'm going to go ahead and create this deployment again because I'll end up using this later in the talk. I'm actually going to go back to my shell container and actually create that again too. Okay. Now that those are created, the next thing I'm going to talk about is Kubernetes services. So once you launch pods in your cluster, it's pretty likely that you'll have other services running inside the cluster that will also want to communicate with those pods. So it would be pretty cumbersome to keep track of all the various IP addresses of the pods so that those other services know how to talk to them. And then also within Kubernetes, pods are pretty ephemeral. So if, let's say, a host were to go down in your cluster, Kubernetes would actually spin up completely new pods, which all have different IP addresses. So to allow services to talk to one another reliably, you would use a Kubernetes service. And then this will define a DNS entry that can be used for other pods to refer to another group of pods in a consistent way. So it's kind of similar in functionality to a load balancer in that you'll have this consistent endpoint that then proxies traffic to other pods. Okay, so I'm going to launch a few services here to show an example of that. So we already had the Nginx deployment launch previously. And if you remember, there was a label that we attached to all the pods in that deployment. So in this service here, we're going to have kind service. It's going to be version v1 again, and we're just going to give it a metadata name of Nginx. One of the important things here is the selector, which just says traffic for the service should be routed to pods with this label. And if you remember, the deployment assigned this label to every pod that was managed by it. So then the service is going to be responsible for routing traffic to all of those same pods. So I'm going to define some port rules here. So we're going to go ahead and route traffic from port 8080 to 80. and then port 80 to 80. So I'm going to do kubectl apply here. And we should be able to see that this service was created. So now if I go and I exec back into my shell container, I should be able to use this cluster IP here to access the underlying pods. So I'm going to copy this and then just try and do a curl on that. So we can see that we hit some Nginx pod, but we don't actually know which one it is. It's possible that within Kubernetes, all the underlying pods could be completely destroyed and then recreated elsewhere, and this service would still be available. So I'm also going to access this via name too, rather than the cluster IP. So the DNS entry is defined as nginx.default, which is the namespace that this was created in. We didn't really discuss namespaces too much in this talk, but everything by default when you launch it via kubectl, it's going to be launched in the default namespace. And then just .svc.cluster.local. Okay, so you can see that we also hit this an Nginx pod in this way too. So if you had one application that was talking to another one, and let's say your application is looking for some service, and then it takes that flag as maybe like a start command or something, you could pass in this value here, and then you would know that as long as those pods are up, then you're going to have that service be available with this DNS entry. Okay, so the next topic I'm going to discuss is that of config maps. So these allow you to store like arbitrary values within Kubernetes and then expose those as either environment variables or as storage within running pods. So imagine you have some application that requires some config file on disk to launch. You could use config maps to actually store it within Kubernetes and then dynamically mount that into the pod at runtime. This would allow you to not have to bake those configuration files into the image itself, which makes deployment a lot easier. So as an example of that, if any of you have ever seen the Nginx image on Docker Hub, you'll notice that they'll actually say if you want to do custom configuration, you can just bind mount in a file from the host into the container, and then Nginx will use the configuration. The problem here is that when you're using a cluster with multiple hosts, the only way to do this would be to ensure that you have this file existing on every host, which is a pretty cumbersome process, and it's also pretty hard to update. So instead what you can do is you can define a config map in Kubernetes and then mount that into the pod or the container basically the same way as here. It just doesn't need to exist on the host itself. So I'm going to show a few examples of that. So in using config maps, the order that you would do this is you would create the config map itself, and then you would create whatever resource actually references it, and then be able to use it. So I'm going to launch, or rather create a pretty simple config map here. So we look at the kind is config map, it's v1 again, and then we're going to give it the name testcm. And then it's just going to be a pretty simple one where key 1 is value 1 and key 2 is value 2. So to create this, I'll use kubectl apply. And we'll see that the config map is created. So I'm going to go and I'm going to use the kubectl get command again with -o flag to see what this resource looks like inside of Kubernetes. Okay, so you can see that Kubernetes itself is actually holding these two keys for us. So now that we have the config map created, I'm going to go and I'm actually going to launch and expose these as pods. So first, I'm going to launch a pod using it as an environment variable. So if we look at this resource here, it's just going to be an Ubuntu container that just sleeps forever. This is just basically something we can use to hold the process open while we go and exec into it later. So under the env command, I can see I'm going to have a key called primary key, which references testcm. And I'm going to set secondary key equal to the value of key 2 from testcm. So now I'm going to do kubectl apply on this pod resource. And then now that's created, I'll just make sure it's running with kubectl get pod. So it's still creating. Let's give it a second for that image to pull. Okay, it's now running, so I'm going to exec into that with the kubectl exec command. then just typing env to see which environment variables were set, we can see that primary key is equal to value 1 and secondary key is equal to value 2. So next I'm going to show exposing that config map as a volume within the pod. So if your application was expecting something to be on disk, you'd probably want to use this method. So here, rather than using an environment variable, I'm going to define a new volume called config volume, and then I'm going to mount that into this first container in the mount path etc config. Now I'm going to create this as well with kubecontrol apply. And then I'm going to go ahead and exec into this. I think I have the name wrong. Volume CM pod. I must have touched something wrong there. Okay, so now I want to navigate to the etc config directory. And we can see here that every key within the config map was exposed in this directory as a unique file. So we have one called key1 and one called key2. And then the values of these files are just going to be the corresponding contents of those config map keys. So we can see that key1 is value 1 and key2 is value 2. Okay, so next I'm going to kind of wrap up the last couple things we discussed in a more concrete example. So the goal here is just to create a new Nginx pod or Nginx deployment that uses an existing config map that will just proxy an external URL. In this case, I'm just going to point this proxy to rancher.com. So one other way to create a config map, rather than creating a Kubernetes resource file, is to use the kubecontrol create commands and then with the -- from file flag. So this will just take a file from your local disk and then create that within Kubernetes. So I'm just going to copy this command here and then create a new config map called proxycm. And the file I'm using here is a configuration for Nginx, just to proxy rancher.com on port 80. All right, so let's create this config map. And then let's do kubecontrol get again, just to show what's inside here. Okay, so we can see that this Nginx configuration is now actually stored inside of Kubernetes, which means it's ready to be used within pods. So now I'm going to look at this proxy deployment. So we're going to have two replicas here of containers. That's just Nginx. We're going to expose it on port 80, and then we're going to reference the existing configuration map that was used, and then mount this into the etc nginx conf.d directory. And this is just the directory that Nginx is by default looking for when it's looking for configuration files. So I'm going to create this deployment with kubecontrol apply. And then let's check to make sure that these are being created with kubecontrol get pod. Okay, so you can see that they're still being created, but we do have two proxy deployments here. Okay, so next I'm going to look at proxy service, which we're just going to use to expose the service within the cluster. It's a pretty simple one, just called proxy, and it's going to route traffic from port 80 to port 80. And it is using the selector at proxy, so it's going to be redirecting traffic to the deployment that we just created. And I'll create this with kubecontrol apply, and then let's do kubecontrol get service just to view it. Okay, so now what I'm going to do is exec back into my shell pod. And then I'm going to curl proxy.defaults.service.cluster.local, which is just the DNS entry for this service. And you can see here that it actually went and proxied rancher.com. Okay, so the next thing I'm going to discuss is that of ingresses. So if we were to want to expose this service to the outside world, maybe like a public IP address, one way to go about that would be to use ingress resources. So ingress is define how you want outside traffic to be routed inside of your cluster. And then there are various factors such as like the host and the path that you can use to have define various routing rules inside the cluster. So now I want to go and create this ingress resource here. So if you look at this file, you'll probably notice that there's these three slashes here, and then there's actually two different resources inside this file. So this is something that Kubernetes allows you to do. If you want to just group together various resources, you can do it in this way, and then it's the same as if you created two separate files with these resources inside of it. So the first ingress resource is one that I'm going to use to expose our proxy to the outside world. So we're going to define that we want to bind to port 9000 for the load balancer that's going to be created, and then it's going to be pointing to the backend service of proxy. And then similarly, we're going to expose the old Nginx deployment that was created earlier. And then if you look at Rancher, when we create these resources, we'll see that what Rancher does is it actually spins up HA Proxer-based load balancers for each of these ingress resources. So I'm going to use kubectl apply to create these two resources. And once they're created, we're going to see that Rancher is going to start actually creating load balancers behind the scenes for these. And then on the right again, I'm going to do kubectl get ingress, just to show that these two resources were created. And then it's also going to tell you the address that these two resources were created on. So in this case, since we didn't really have any scheduling rules, these load balancers are going to be scheduled randomly by Rancher. And then if you look at our hosts tab, we can see that the two load balancers were spread across two random hosts within our environments. And then the address of these two hosts are what are used for the kubectl get ingress address. So for Nginx, remember that was on port 9001. This load balancer here is actually bound to that host port. So we can actually go and then look on port 9001. And we can see that it routed traffic inside of the cluster to one of the Nginx pods. And then similarly, let's check out the proxy, which we defined on port 9000. We can see that it routed traffic to the proxy service within the cluster. So this is a pretty simple use case of ingress resources, but you can also define more complicated routing rules. And then you can also do different scheduling rules for the load balancers themselves. So maybe in your cluster, you want to have a group of hosts that are defined, are there just for the purpose of providing ingress load balancers. And then you could, say, scale these load balancers across all of the hosts in that group. Okay, I think that's all I have to cover. So if there are any questions, I think now would be a good time to ask them.
I haven't gotten any questions for a while, for a little bit. So if there are any questions in terms of what Josh has demoed, please ask. I think probably the one is to follow back. I didn't want to interrupt because of what you were demoing, but to go back to, I think the person who had asked about if you could do like multiple containers in in one YAML file. I think they're trying to figure out like how would you be able to do like the similar concept of in Docker Compose, you can put have a Compose file that has multiple containers or services in it, and how would you be able to do that in Kubernetes YAML file?
Yeah, so each deployment is kind of like one service within a Compose file. So if you, the last resource that I created, I showed that you can actually have two different resources with the same file. So you could actually do the same thing for deployments. It's not quite as dense or grouped together as a nice Compose file is, but this is just kind of the nature of Kubernetes and how things are created there. If you look at like what Helm does, each Helm chart, I can pull up an example here. Each Helm chart is kind of a group of various Kubernetes resources that are upgraded together, which is kind of like what a stack is in Swarm or Rancher. Let's just look at the Datadog one. And if you look at like the templates directory here, you can see that there's a bunch of different resources. So they're not all in one file, But if you're using some like higher level tool like Helm, you can package these all together and then deploy these all at the same time. All right, other questions?
So someone asked if we can comment on Kubernetes support for Docker, like C, the community version. So Kubernetes itself still only, even with their latest release, only supports up to Docker 1.12.6. So 17.03, 17.06, the community or enterprise edition are not supported by Kubernetes. Therefore, like Rancher itself doesn't support it. Whenever Kubernetes decides to be able to support those versions, we will also have that support as well.
And in general, the Docker version, when you're using Kubernetes, doesn't mean too much. A lot of the features that are in Docker aren't actually exposed within Kubernetes, so switching around versions, you won't actually see much as an end user.
Yeah. Let's see. I think that's most of the questions, at least I see, that we can answer. I know there, I think I answered most of them. Let's see, there's this one. But otherwise, I mean, oh, could you go, I know you're sharing your screen, or I hope you still are.
Go back to.
Can you go to the slides?
Oh, yeah.
Basically, the last point of resource that there is out there is Slack. So we actually have a lot of our community is on Slack. A lot of actually the employees of Rancher are on Slack or on the users channel. Though I will caveat that if you ping us directly, it does not mean we will definitively answer. We will try our best when we have time. But the community is super active. You can join here, slack.rancher.io. There's a specific Kubernetes channel. So if you have questions about Kubernetes itself, please go there and ask them. There's also like a general Rancher one. So if you're getting setting up Rancher, you can go and ask questions there. Otherwise, I just want to say thank you so much, everyone, today for coming. I just saw a couple of questions come in. I'll probably like stop recording. Oh yeah, this demo is recorded. I think it becomes available on our YouTube channel. At one point, marketing will put it up there so you can watch it again if you want to. I think you get, after the webinar, they'll email you with a link to it maybe as well. And then, yeah, if you have any questions, please feel free to come again and see our same demo if you want further questions. I'm probably going to stop the audio. I'll try and answer a couple more questions that have suddenly come in. And everyone have a great day. Thanks.